Dear all, in this video I'll be discussing the design procedures of impulse generator. Before explaining the design, the working will be explained in my previous video and the video link is given in description box. Kindly go through that particular video link so that you can able to understand how does an impulse generator operate, how does it work. However, let me discuss about the design of impulse generator. I am going to show 3 to 4 examples. Based on that particular examples, I'll be explaining the design in a simple manner. I'll promise you that at the completion of this session, definitely you will be getting some idea about impulse generator design. So please watch this video completely. Moving on to the first example. An impulse generator has 8 stages with each condenser rated for 0.16 microfarad and 125 kilovolt. The load capacitor available is 1000 picofarad. Find the series resistance and the damping resistance needed to provide 1.2 bar 50 microseconds impulse wave. What is the maximum output voltage of the generator if the charging voltage is 120 kV? First and the foremost, better write the given data. There are 8 stages, so I have noted down n is equal to 8 and the capacitor rated for 0.16 microfarad. The generator capacitance that is given by 0.16 microfarad. But there are 8 stages. Therefore, the generator capacitance C1 that is given by the given capacitance divided by number of stages. Therefore, I have got 0.16 divided by 8, that is nothing but 0.02 microfarad. You can directly observe here. This is called the generator capacitance. Afterwards, what I did is C2 has been noted down. What is the value of C2? 1000 picofarad. But C1 is expressed in terms of microfarad. It is better to maintain C1 and C2 in the similar unit. Normally, we are expressing these impulse generator capacitance in terms of microfarad. Better you can go for the load capacitance also in microfarad. So 1000 picofarad that is equal to 0.001 microfarad. Afterwards, what you are supposed to do is you can note down the wavefront time. Here, the wavefront time is equal to 1.2 microseconds and the wavetail time is equal to 50 microseconds. That you can directly note down. And also the charging voltage of a single stage that is given as 120 kV. If you want, you can able to calculate for 8 stages. For one stage, the charging voltage is equal to 120 kV. Therefore, the charging voltage for 8 stages are given by 8 into 120 kV. That is nothing but 960 kV. That also you can note down. Here, our ultimate goal is to compute the wavefront resistor. You can call it as series resistance, and the wavetail resistor, you can call it as damping resistor. You are supposed to calculate series resistance and the damping resistance. You can call R1 equal to series resistance and R2 is equal to damping resistance. That is your ultimate goal. Okay. Now let us discuss an equivalent circuit of a particular impulse generator. As you can observe, this is an equivalent circuit of impulse generator. We have source that is called generator and it is having the capacitance C1 and there is a sphere gap G, R1 and R2. R1 is called series resistor or you can call wavefront resistor. R2 is called damping resistor or you can call wavetail resistor. So by selecting the suitable value, you can maintain the suitable wave shape. That is the peculiarities of R1 and R2. C2 is known as output capacitance. We should calculate the maximum output voltage which can produced by the impulse generator. That is represented by V naught of T in terms of a time as a function, time function. So our ultimate goal in this design is R1, R2 and V naught. That is our ultimate goal. So we have noted down all the given data. Now, as you know that the wavetail time can be computed by using the formula T1 equal to 3R1 into C1 C2 by C1 plus C2. Here substitute the value of T1, C1, C2. In the denominator also you can substitute C1, C2. Finally, from this expression you have to do the simplification and you will be able to get the value of R1. So R1 will be approximately 420 ohm. Better you can go for a standard value of resistor. I don't think so 420 ohm is directly available in the market. You can go for the standard value. Similarly, you can able to go for wavetail time. Use the equation 0.7 R1 plus R2 into C1 plus C2. 0.7 means 70%. Now you have to substitute the value of T2 here. Then R1 we have computed, that is 420 ohm. So same value can be substituted. Similarly C1 and C2 that is available in the question. After substituting, you can do the simplification. Further doing the simplification, you can able to get the value of R2 is equal to 2981 ohm. So we have got R1 and R2. Now how to get the maximum output voltage of a given impulse generator? You have to use the given formula V naught maximum, that is given by charging voltage V divided by R1 C2 into alpha minus beta into e to the power minus alpha T1 minus e to the power minus beta T1. Please do remember this equation. This will really help you out. So what is alpha and beta? Alpha is nothing but 1 by R1 C2. What is beta? 1 by R2 C1. Do remember this formula. First, it is better to calculate alpha and beta separately. R1 and C2, that value we already computed, and R2 is already computed, and C1 is available in the question. Then alpha and beta can be computed. Once you get the value of alpha and beta, you can able to substitute the value of R1, C2, alpha, beta in this expression 3. So this is the expression for calculating maximum output voltage. Use the calci, do the computation accurately, substitute properly. Finally, you will be getting V naught maximum, that is equal to 932.6 kilovolt. You know, this much of voltage can capable of producing by that particular impulse generator. Okay, so this is the way how to calculate the maximum output voltage which you can generate with the help of given impulse generator. So in this example, we have been provided with the C1, C2 and also the charging voltage, okay, then wavefront time and wave tail time. Then we could compute R1, R2 and the maximum voltage which can produce by the given impulse generator. So this is a simple design. In continuation with the same question, I'll be putting up the similar manner another example. A 12-stage impulse generator has 0.126 microfarad capacitors. The wavefront and wavetail resistance connected are 800 ohm and 5000 ohm respectively. If the load capacitor is 1000 picofarad, find the front and tail times of the impulse wave produced. Here there are 12 stages of impulse generator. There are 12 stages. Then generator capacitance is given and the load capacitance is also given. Then R1 and R2 is also provided for you. So you need to compute what is the value of R1 and R2. Sorry, you need to calculate what is the value of T1 and T2. That means wavefront time and wavetail time have to be computed. R1, R2, then C1, C2 and N, everything is provided. You are supposed to compute T1 and T2. First of all, better draw the equivalent circuit. You will be getting an idea. The generator capacitance, load capacitance, R1, R2, then sphere gap. So this is an equivalent circuit of impulse generator. First, you have to calculate generator capacitance. You know N is equal to 12. C1 is equal to 0.126 divided by N. That is nothing but 0.0105 microfarad. Likewise, load capacitance is given in the question and also R1, R2 both are available. So note down. Now you have to use the formula of wavefront time T1 equal to 3 R1 into C1 C2 upon C1 plus C2. So direct substitution can be done. R1, C1, C2, all the values are available. So directly you do substitution. Finally, I'll be getting the wavefront time that is equal to 2.19 microseconds. Please do verify this answer by yourself. Likewise, I can able to compute wavetail time T2 is equal to 70% of R1 plus R2 into C1 plus C2. So after substituting the value of R1, R2, C1 and C2, I can able to get T2 is equal to 46.7 microseconds. I hope you will verify the same answer. Okay, so I could get the value of T1 and T2. So this is another example. Now I would like to show you one more example. So before showing the example, you have to familiar the given table. This table will help you out for doing the design procedure. Let's consider table 1. This table comprises of different waveforms like 0.5 bar 5 microsecond, 1 bar 5 microseconds, like 1 bar 50 microsecond, 8 bar 20 microseconds. And LC combination, LC constant is available here for respective waveforms. And also they have given the RC constant. For example, 8 bar 20 microseconds waveform, the RC constant will be 6.955. And also they have mentioned the voltage efficiency. Voltage efficiency is highest in this combination, 1 bar 50 microseconds. And voltage efficiency is least in case of 8 bar 20 microseconds. That is also merely visible here. This table has to be remembered. Remember, R is expressed in terms of ohms, capacitance is expressed in terms of microfarad, and finally inductance is expressed in terms of microhenry. These terminologies you have to remember. See, likewise, there is another table, that is table 2. Okay, as far as our design concerned, we have to call it as table 1 and table 2 respectively. In the table 2, you can see the waveform. So different combinations are available like 0.5 bar 5 microseconds, 1 bar 5 microseconds, 8 bar 20 microseconds. Likewise, different combinations, different waveforms. Here alpha value, alpha is nothing but 1 by R1 C2. That is already given, alpha. Similarly, beta, beta is nothing but 1 by R2 C1. Okay, so that value is also very clearly provided. And output voltage V0 1.225, 1.892 for respective combinations. So please to remember this table for your reference. This will 100% help you out for the design. Now I wanted to explain how these tables are helping you out for the design of a given impulse generator. Okay, the requirement will be deferred. So according to that, you have to recall this table. Okay, now I would like to show you the third example that will really help you out for doing the proper design of impulse generator. Moving on to the example. A model impulse generator has a capacitance of 1 microfarad rated to 10 kilovolt and uses series RLC circuit to produce 1 bar 50 microsecond voltage wave. Clear? There are two parts. The first part is you have to determine the resistance and inductance needed to produce the same and the output voltage across the resistance. That is the first procedure. The second question, if the same circuit is to be used to produce another waveform like 8 bar 20 microseconds, you must have familiar different combination like 1 bar 50 microsecond, 8 bar 20 microseconds. So if the same circuit is to be used to produce 8 bar 20 microseconds impulse voltage wave, what are the other parameters? Okay, you can able to compute I peak. What is the peak value of current? You can able to compute. So these are the things you need to calculate. For solving this design procedure, you have to refer table 1 and table 2 effectively. Then only you can do the design of this particular example. First in the foremost, better draw the equivalent circuit of impulse generator. We have C, that means generator capacitance. There is a sphere gap, then inductance L, and output resistor R. So basically it is an RLC combination. It is very clear. Refer table 1. So look at 1 bar 50 microseconds. Please note down the value of RC and LC. I have referred the table already and I could note down the value of RC is equal to 70.6 and LC is equal to 11.6. Let us cross verify if you want. Go to table 1 and check out for 1 bar 50 microsecond waveform. Here obviously LC is equal to 11.6 and also RC is equal to 70.6. It is very clear. You have to note down those particular values on your notebook or data sheets or your particular rough book. So you know LC is equal to how much? They have directly given us LC is equal to 11.6 and RC is equal to 7.6. I know the value of C, that is equal to 1 microfarad, that is given in the example. So now RC is equal to 7.6. Therefore, I can compute the value of R. R is nothing but 70.6 divided by C. That is nothing but 70.6 ohm. I have computed the value of R. So look at the second segment. LC is equal to 11.6. From this expression, I can calculate L. L is equal to 11.6 divided by So finally, from this expression, LC is equal to 11.6. From this expression, I can compute L, that is nothing but 11.6 divided by C. I know the value of C, that is equal to 1 microfarad. Finally, I have got L is equal to 11.6 microhenry. So I have computed the value of R and L. You know that table 1 gives the voltage efficiency also. Voltage efficiency is given as 98.8% for this combination. It is very clear. If you want, you can refer that particular table. This is just for your information. Look at this, 1 bar 50 microsecond, the voltage efficiency is highest, that is given as 98.8%. So you can recall that particular information. The output voltage that is given by 9988 into 10, that is nothing but 9880 volt. From this expression you can able to write directly. It is better to convert into kilovolt, that is equal to, in terms of kilovolt, 9.88 kilovolt. So output voltage that is determined by 9.88 kilovolt. So this is also a very simple procedure. If you refer table 1, you will be getting voltage efficiency. Then using this expression, you can able to get the total output voltage produced by the impulse generator, that is equal to 9.88 kV. Let us look at the second part of the question. Second part is, if the same circuit is to be used to produce 8 bar 20 microsecond impulse voltage wave, what are the other parameters? So you are going to go for other combination, that is 8 by 20 microseconds. Here wave tail is equal to 20 microsecond, wavefront time is equal to 8 microsecond. Now let us recall table 1. For 8 bar 20 microsecond, you have to note down LC, then alpha, etc. So let us go back to table 1 and you have to refer 8 bar 20 microsecond. Table 1 and table 2 both are required. So table 1, 8 bar 20 microsecond. LC value is equal to how much? 65. RC combination, that is equal to 6.955. I need this LC value, 65. Let us look at the table 2. For 8 bar 20 microsecond, the alpha is equal to 0.0535. Please remember this value. Now let us write the same thing over here. Okay. LC is equal to 65. I know the value of C. From that I can able to calculate L. So L is nothing but 65 by 1. So after using this equation, L is equal to 65 microhenry you will be getting. Okay. Now we can have one more expression. Alpha is equal to R divided by 2L. Alpha value will be obtained from table number 2. Please do refer the value of alpha from table 2, which I have shown you a bit early. So alpha is equal to 0.0535. R by 2L is equal to alpha, that is equal to 0.0535. From this expression, I can able to compute R. So R is nothing but 2L times 0.0535. So L is equal to 65 microhenry. Therefore, directly you can substitute and finally you will be getting the answer for R is equal to 6.955 ohm. So what I have got is L is equal to 65 microhenry and R is equal to 6.955. So I have computed the two parameters. The third parameter is I peak. What is the peak value of current? The peak value of current expression is given by Vc upon 14. So this is a standard expression which are concerning for impulse generator. Please do note down this expression. I peak is equal to Vc upon 14. Now, from this expression, we can able to say that Vc by 14. Okay, Vc by 14. That is equal to I peak. Now, you know the value of V. So what is the value of V? They have given in the question. Look at, refer the question once again. Recall the information. See the voltage, capacity voltage, that is equal to 10 kV. So that is equal to V. V is equal to 10 kV. Okay, V is equal to 10 kV and C is equal to 1 microfarad and 14 is a constant. Therefore, I will be getting the I peak, that is equal to 0.714 kilo ampere. 0.714 kilo ampere is nothing but 714 ampere. So I peak is equal to I peak. Peak value of current is equal to 714 ampere. So this is another parameter. So in the second segment, I have computed the value of L. Later on, I computed the value of R. And finally, I could get the value of charging current. Peak value of charging current, that is equal to I peak. That is nothing but 714 ampere. This I have got it from the particular table 1. I have referred table 1 and table 2 and recall the standard equation. Okay. So in this question, I could get the value of R, how to compute the value of L, how to compute the value of I peak. Okay. Hope the design procedure is very clear to you. So let us recall what we have done right from the beginning. So at the starting itself, we have computed the value of R1 and R2. So how to calculate R1 and R2? R1 is nothing but series resistance, or you can call wavefront resistance. Then R2 is nothing but damping resistance or wavetail resistance that you can compute. That procedure I have explained. So later on in the second design procedure, I have explained how to calculate wavefront and wavetail time. So expression I have already given, T1, that is equal to 3R1 into C1 C2 by C1 plus C2. Likewise T2, there is another expression, 0.7 into R1 plus R2 into C1 plus C2. So that is another expression. Later on I have explained how to calculate the maximum output voltage. Using this expression, you can able to compute the maximum output voltage. Please do remember this expression. Okay. Then from this expression, how to calculate alpha and beta. There is another expression, 1 by R1 C2, beta is equal to 1 by R2 C1. So this expression also will help you out to compute the maximum output voltage. Afterwards, I have shown you two tables. There are two tables. Okay. Standard waveforms and corresponding parameters. This table will be helping you out to get the values of RC and LC constant and also voltage efficiency. Likewise, you can able to refer the value of alpha and beta by referring table 2. This one also will help you out for designing problem to compute the value of L, C, R, etc. So this example reveals how to compute the values like L, C, etc., R, and the peak value of charging current, I peak. Okay, these are all the procedure we have discussed. These are the few basic procedure which will be helping you out for the design of impulse generator. You may refer the theoretical part in my previous video. I have explained elaborately. Let me know if you are having any queries. Finally, thank you very much for listening to this video.